Hello, Math 10Cs. We're going to do part 2 of factoring simple trinomials. All right, just do a quick review of factoring by inspection. In order to factor x squared plus bx plus c by inspection, we need to find two integers which have a product equal to the c value and a sum equal to the b value. If no two integers exist, then the polynomial cannot be factored. Good, we talked about that last day. In order to factor x squared plus 6x plus 9, we must now find two numbers who have a product of 9 and who have a sum of 6. In order to factor x squared plus x minus 12, we need to find two numbers who have a product of negative 12 and a sum of positive 1. Recall the following points from the previous lesson. If the product is positive, then the two integers must be either both positive or both negative. And if the product is negative, then one integer is positive, the other one is negative. Let's remember how to do a couple of these. Remember, if we're going to end up with a trinomial, the only way to get that is to have two binomials multiplied together. We want to come up with an x squared as our first term. The only way to get that is to go x multiplied by x. And I'll ask myself what two numbers have a sum of negative 1 and a product of negative 12. So the only things that multiply to negative 12 and add to negative 1 are minus 4 and plus 3. Therefore, the factors of x squared minus x minus 12 are x minus 4 times x plus 3. If I want to factor the next one, make our two binomials. The only way to get to x squared is x times x. We ask ourselves now what two numbers have a sum of positive 3 and a product of negative 18. So two numbers that multiply to negative 18 and add to positive 3 are positive 6 and minus 3. And the last one, now the variable is a. So a times a in my binomials will give me a squared. And what two numbers sum to negative 7 and multiply or have a product of negative 8? Those two numbers are minus 8 and plus 1. Example 2 asks us to factor where possible. That's usually a hint that maybe there is a situation here that is unfactorable. So let's start by making our two sets of brackets. The only way to get to a squared is to have an a in the front. Ask ourselves what two numbers have a sum of positive 6 and a product of negative 27. Think about that for a few minutes. Think of all the things that multiply to 27. If you have trouble with this, let's write all the factors of 27. 1 times 27, 3 times 9. Those are the only factors of 27. Do any of these ever add up to 6? And remember, we can have one positive and one be negative. So I notice that 9 and 3 have a difference of 6. So if I take a positive 9 and a negative 3, that adds up to 6, and that gives us a product of negative 27. Part B, common mistake. If I ask myself what two numbers sum to negative 14 and multiply to 20, might not find anything. All things that multiply to 20 are 1 times 20, 2 times 10, 4 times 5. None of those add up to 14. You're going to can't be factored, which isn't true. All right. What you have to do is ask yourself, is there a common factor? So I notice that there's a 2 common to every single term, so I want to take out my common factor of 2 first. So I divide every term by 2. So 2t squared divided by 2 is t squared. Negative 14t divided by 2 is a negative 7t. And positive 20 divided by 2 is a positive 10. And now I look at the trinomial and ask what two numbers have a sum of negative 7 and a product of 10. So things that multiply to 10 are 1 times 10 and 2 times 5. So I want to finish factoring this polynomial then. I make my two sets of brackets, remembering to keep the common factor of 2 in front. The only way to get to t squared is to go t multiplied by t. And the two numbers that sum to negative 7 multiply to 10 are 2 and 5, and these must both be negative. So there are our factors for part B. If we look at part C, There's only one thing that multiplies to x squared. What two numbers have a sum of negative 3 and a product of negative 6? So again, if you're not sure, multiply all the things, write down all the factors of 6. 1 times 6, 2 times 3, those are all the factors of 6. 1 plus 6 is 7, 1 minus 6 is 5, 2 plus 3 is 5, 2 minus 3 is 1. So no product will ever give us a sum of negative 3, so this is not factorable. If we look at D, just like part B, I notice there's a common factor first, and we should always look for the common factor first. So every term here can be divided by 4x squared. That's our greatest common factor. So I divide every term by 4x squared. 4x to the fourth divided by 4x squared leaves me x squared. Negative 16x cubed divided by 4x squared is a minus 4x. And negative 20x squared divided by 4x is a minus 5. If I'm going to factor this, I keep my common factor, and I know in my trinomial, I'm going to need two binomials. The only way to get to x squared is to have x times x in the front of my binomials. And now ask yourself, what two numbers sum to negative 4 and multiply or have a product of negative 5? And again, if you write down all the things that multiply to 5, there's only one set of numbers that multiply to 5 that are integers. They're 1 and 5. So they must sum to negative 4 if I say 5 is negative and 1 is positive. And they would also multiply to negative 5. So that's a complete factorization of part D. Factoring trinomials of the form x squared plus bxy plus cy squared. All that's happening now, instead of being in one variable like x, we're adding another variable like y. Everything else is pretty much the same. So let's just look at this example. It nicely illustrates what's going to happen if we introduce a second variable to our trinomial. If I expand x plus 2 by x plus 4, I end up with x squared plus 4x plus 2x is 6x, and then 2 times 4 is 8. Therefore, x squared plus 6x plus 8, if I factor that, I'm going to be left with x plus 2 times x plus 4. Makes sense? Expanding, that's on top. Factoring, that's on the bottom. Part 2 then says x plus 2y times x plus 4y can be expanded as x times x is x squared. Then I get 4xy plus 2xy gives me a positive 6xy. And then I get 2y times 4y is a positive 8y squared. Looks very similar to the expansion of x plus 2 and x plus 4, except I've added the variable y. Therefore, if I look at factoring x squared plus 6xy plus 8y squared, if you're asked to factor that, it's still a simple trinomial because there's a 1 in front of the x squared term. That factors as there's only one way to get to x, that's x, only one way to get to x squared, that's x times x. And now what two numbers sum to 6 and multiply to 8? Well, we've seen that they're 2 and 4, but now they must be 2y and 4y. So we just end up with a second variable in the back of each bracket of our factors. So if we're asked to factor x squared plus 13xy plus 30y squared, we're going to do the same thing we've been doing. Make our two sets of brackets. The only way to get to x squared is put an x in the front of each bracket. And if you'd like, the only way to get to y squared is to put a y in the back of each bracket. So you could label finish off your variables right off the start. And now ask yourself, what two numbers have a sum of 13 and a product of 30? The other things that multiply to 30 that add to 13 are 10 and 3. So it's going to be plus 3y plus 10y. How do you know if you got it right? Well, you expand out your binomials and make sure you end up with a trinomial to start with. So x times x is x squared plus 10xy plus 3xy is 13xy, and 3y times 10y is 10y squared. So you can always check to see if you got it right by expanding. Part B, make our two sets of brackets. The only way to get to x squared in the front of each bracket is to have an x, and the only way to get to y squared at the back is to have a y in the back of each bracket. Y times y will give us y squared. We can now do our sum product idea. What two numbers have a sum of 71, a product of negative 72? Well, there's lots of things that multiply to 72, but there's only one that's going to have a difference of 71, or a sum of 71. That's going to be positive 72 and minus 1. So there are your factors: x plus 72y, x minus 1y. And finally, part C. Step 1, we should always look for a common factor. Is there a common factor of 3a squared minus 15ab minus 252b squared? That's what you have to ask yourself. So if there is a common factor there, let's take it out. So the common factor in these three terms is a 3. Divide every term by 3, and I'm left with 1a squared minus 5ab minus 252 divided by 3 is 84b squared. So now we're in a situation where I keep my common factor of 3, make my two sets of brackets, and ask myself what two numbers add to negative 5 multiply to negative 84. So again, if you're stuck, make a list of every possible factor of 84. So 1 times 84, 2 times 42, 3 times 28, 4 goes into 84 21 times. 5 does not. Try 6. I think 6 times 14. 7 also goes into 84 12 times. And 8, 9, 10, and 11 do not. So then we'd start working back up the other side. So we know we've listed all our factors. So if I look at that list of factors, which of these would ever add to negative 5? Well, obviously not 1 and 84. That'd give me 83 and 85. 2 and 42 would be 40 or 44. 3 and 28 would be 31 or 25. 4 and 21 would give me 17 or 25. 6 and 14 would give me 20 or 8. That's getting close to 5. 12 and 7 would give me 19 or 5 if one of them is negative. That's the only one that's going to work. So those are going to be the numbers we need. So the only way to get to a squared if I'm factoring is to have the a in the front of each bracket. And then the two numbers that add to negative 5 multiplied negative 84 are 12 and 7. We needed 12 to be negative. So negative 12b, have to get the b squared at the end, and a positive 7b. Alright, so that's it. If you have any questions about what happened in this lesson, make sure you ask tomorrow in class. And tomorrow in class we'll work on numbers 1 through 11. So that'll be the class assignment. You don't have to do that for homework. We'll see you tomorrow.